Hi everyone, this is Rachel and I'll be doing a short Aerovis tutorial using one of Aerovis's built-in examples called LTM, which stands for long-term monitoring. Um, these examples are available on the Aerovis user site. You'll find them in a folder called examples2012.zip, and once you unzip the file, you'll see that there are 4 different examples you can work through, and the one we'll be talking about today is called LTM. So before we open up Aerovis, I'm going to show you what the input files look like. So at a minimum, you need to have a file that you'd like to plot in Aerovis. So this is our .out file. The extension on this file doesn't matter as long as it's formatted in this way, and you'll see more information in the Aerovis user's guide about formatting files. But for this one, the most important thing to note is that your objectives, cost, error, risk, and mass, are located in columns 4, 5, 6, and 7. And after that are the decision variables associated with each file. And between these 2 pound signs is the size of the total reference set. So your .par file is what you'll physically open in Aerovis. And you'll need a little bit of information. Aerovis also now has drag and drop functionality. So if your file is formatted like this LTM.out file is, you'll be able to simply drag and drop it into the Aerovis workspace. So within LTM.par, we need to tell Aerovis where our data files begin and end and attach a name tag to it. So LTM.out is our file located in the same folder, and the name of the file is called LTM. The next tag we need are the tags for the objective values. So our objectives are in columns 4, 5, 6, and 7. That's what this first value is. The next value in each of them are the min and max of the objectives. The next value is whether we want to minimize or maximize our objectives. And then the final column is how we want that objective to be displayed. So your display options are X, Y, Z for axes. And then we also have 4 objectives for C for color, O for orientation, S for size, and T for transparency. And the final value here is how we want the numerical value to be formatted. So this is just a C format string. Okay, so now we can go to Aerovis and open up this file. So we'll go to New Project, navigate to the LTM folder, and you'll see LTM par. So we'll open that, and everything pops up like this because we've told the .par file how we want our space formatted. So if we look at this space, it's a 4-objective minimization problem. So we want blue solutions with low cost, so the minimum of cost is located here, low risk, and low error. So we see that our utopia point is in this back corner behind the solutions. And since this file is large, it'll take a minute to move, but if I drag the space around using left click, you can see that none of the solutions fall on the utopia point, which makes sense because the objectives conflict. So here I'm going to go through a quick walkthrough of showing how the solving a 4-objective problem is better than solving the subsets of 2-objective problems. So I'm going to go to the non-domination sort tools. You can get to that through tools, non-domination sort. I already have that open here. So we're going to go to cost and error, and we'll sort them with an epsilon coarseness of 1, which means that we'll reduce the thickness of this set and reduce it to a more manageable size. You can find another video talking more about epsilon dominance on the YouTube channel. So we're going to perform sort for those 2 values, and we're going to mark them. And now to change the options on marking, we go to Tools, Marking Tools. And I'm going to label this cost error so I remember what the trade-off is. And we're going to bump up the size to 2 so it's a little bit easier to see. Okay, now we'll go back to non-domination sort, and now we're going to sort through cost and risk with an epsilon coarseness of 1. So we change the check marks on here, and we revert to full set, since we need to sort a different set. This will take a minute because the full set is pretty large. Okay, and then we're going to sort the other objectives at epsilon coarseness of 1. And we'll go back to marking. Oh, we have to click mark non-dominated, and we'll go back to the marking tools and label this cost risk, and also bump up the size to 2 so it's easier to see. Okay. Alright, so now we can go back to the non-dominated set. We'll revert to full set, and we'll thin it out a little bit more just so this program runs faster. It runs slower based on more solutions. So if we want high interactivity, we need to have smaller reference set sizes. So now I'm going back, I'm checking all the boxes, sorting them at an epsilon of 1. So we thin out the full reference set. Okay. So now, given that we've sorted the two objective problems, we can look at the space, and let's focus in on this corner because it has low risk, low error, low mass error, but it has a high cost. And you'll see that this solution in the corner is the high cost solution because it samples nearly every well in the space. So if we right click and push your mouse up, that's the zoom tool. So we'll focus again on this corner of the space, and we see that for the cost error to objective problem and for the cost risk to objective problem, we get some values with a fairly high mass error, which is not ideal. But if we continue to zoom in on this space, we see that there are some compromise solutions here. Zoom out just a little bit. We see that we have solutions with low risk and low error, and for a small decrease in cost, so you're saving money, you still get solutions with low mass error. And these blue values between the two trade-off spaces, we would not be able to find had we only solved the two objective problems, which are marked here in red and blue. So this is just a small demonstration of Aerovis's capabilities and an example of why you would choose to solve a harder four-objective problem rather than two separate two-objective problems, because you can explore areas of the objective space that aren't possible when you only solve a two-objective problem. Thanks for watching this practical example of using Aerovis.